One of my favorite tools for ratio questions is this chart method, which can be used to solve quite a few GMAT ratio questions. In particular, it makes quick work of just about every question that gives you some kind of ratio and gives you some actual value. For example, maybe a question tells us that George goes to the store and buys apples, bananas, and cherries in the ratio of 2 to 3 to 5. So they give us a ratio and they give us some kind of actual value, and that could be many different things. They give us the ratio relationship and then they tell us, I don't know, they say altogether George buys some number of apples, bananas, and cherries. Or they just tell us, well, he comes to the store with exactly 25 cherries. Or they tell us even something like he buys 30 more cherries than apples. In any of those scenarios, we can solve the question pretty quickly and I think pretty intuitively with this chart. So the chart works like this. This top row we'll call the ratio row. This bottom row we'll call the real row. And the whole idea here is finding a quick way to transition from the ratio world up here to the real world down here. And the middle row is just about how we get from the ratio world to the real world. So to illustrate, we'll use my example here. I've got three elements, and we'll put columns for each, A, B, C. And our ratio, we've got A to B to C is 2 to 3 to 5. And that's all in the ratio world up here. And then to continue using the chart, we're going to need something real, some actual value. So first, let's say the question gives us this ratio, and it tells us that George leaves the store with 20 cherries. So George leaves the store with 20 cherries, and well, now we've got an actual value. Now we've got something to put in the real world row, and that's the number of cherries, so that goes down here. So then the question is, well, how do I get from the ratio world to the real world? And now we've got one column with two pieces, so we can say, well, to get from 5 to 20, we multiply by 4. And that's just going to be carried over to every row. That's how ratios work, right? If I multiply every element of a ratio by the same number, I'm not changing the ratio. I'm just expressing it a different way. This 2, 3, 5 could be, if I multiply everything by 2, say, it could be 4, 6, 10. If I multiply everything by 100, it would be 200, 300, 500, and so on. Here I know I'm multiplying everything by 4, so that's what this middle row does. We can think of that as our multiplier row. And then maybe my question was asking, how many apples does George buy? Well, we know it's now 2 times 4 is 8. If he had 20 cherries, that would mean 8 apples. So that's the idea. We get the ratio and we get some element to put down here, and then it's a quick way to just sort of visualize how we can get the other elements. But they don't have to give us one of the specific elements. They could have said, as I mentioned before, they could have said maybe our actual value is not directly the apples, bananas, or cherries. Maybe the actual value is the total. So let's say they tell us that altogether, when George comes out of the store, he's got 90 items, assuming he only buys apples, bananas, and cherries. He's got 90 pieces of fruit altogether. So we've got a bit of an issue for using the chart, which is there's nowhere to put that 90. And I guess this is when I start to really like this chart, and so the reason I drew it like this with these lines extending here is the ratio world, the real world, not limited to just the elements. We could add a column. We could add multiple columns as we want. And here, because I'm given a total, I just want to add a total column. So my total is 90, and that's the actual value, so that's going in the real world. 90 down here. And, well, what is that up here in the ratio world? Well, in the ratio world, my total is just 2 plus 3 is 5 plus 5 is 10. My ratio total is 10. And now we've got a column with two items. We've got analogous elements in the ratio world and the real world, so we can get our multiplier. 10 times 9 is 90. And then we could ask whatever, or we could answer whatever they're asking. Again, maybe they're asking for the number of apples, and we say, well, our multiplier is 9, so the number of apples is 2 times 9, or 18. So, an efficient way to solve this pretty classic question, when you get the ratio and you get the total, nice way to think about it is just finding this multiplier, and the chart's a good way to organize your thinking. I think even more than the total example, I like when they give some less expected thing for the actual value. Maybe the question is this. Maybe the question is, George goes to the store, buys apples, bananas, and cherries in this ratio, and he comes out of the store with, let's say, comes out of the store with 27 more cherries than apples. So a little different. 27 more cherries than apples. And maybe I'll change the question a little bit. Rather than asking for the number of apples, I'm going to ask how many apples, bananas, and cherries all together does he buy? So this time I'm giving, what's that, a difference, right? 20 more cherries than apples, and I'm asking for the total. So again, we can go to our chart. The actual value I get here is the difference between C and A, 27 more cherries than apples. So I'm going to add a column for that. This column will be my C minus A column, cherries minus the apples. And now I've got somewhere to put my 27. That's the real difference between cherries and apples, so my 27 goes down here. And, well, what is my ratio world difference? Again, I just work with the ratio numbers. So C minus A in the ratio world is 5 minus 2, or 3. And once again, we've got two items in a column, so we can get our multiplier. 3 to 27 is times 9. So I could multiply everything across and get all the totals here. Certainly that would be a good way to solve it, but to take full advantage of the chart, we can also add another column. And this one is going to be, well, I'm asking for apples, bananas, and cherries all together, so I'm going to make this column the total column. And, well, what's my total in the ratio world? The total is just the sum of the different items, different elements. So my total in ratio world is 10, and I've got my multiplier now, so it times 9, and that way we can find, oh, it's 90 elements, 90 items altogether that George buys.